Okay, chapter 4 is chemical reaction, right? Chemical reaction, what do you need in chemical reaction? You need a pot, right? You need some reagent, right? You need solvent, solution, and solute, right? So this chapter have like a lot of new vocabulary. We'll go over them first, then we'll go into the topic. Guys, this chapter is the longest chapter in this book. After chapter 4, you'll be a little bit relaxed, chapter 5, 6, so on. It's going to be a short chapter. But chapter 4 is the longest one. You're going to be spending maybe instead of 2 classes, maybe we need 3 classes maybe. Let's see how it goes. First of all, we talked about chemical reaction. Maybe we can talk about the solution. What is solution? What is solution means? What do you need for solution? What is made of solution?
Solute and solvent.
Solute and solvent. What types of mixture it is? Homogeneous or heterogeneous? Homogeneous. What is the key word I said in the last class? Dissolve. Anything dissolving, that means it is homogeneous. It is a solution, right? So, solvent is the one who doing this dissolving process, and solute is the one being dissolved in the solvent, right? So, is everything soluble in this world? No, everything is not soluble. So, soluble to what? We'll talk about the solubility, right? So soluble, something should be soluble to something, right? So like for example, solvent. Solvent, let's see, water, yes, water. So water is the one standard, you can say universal solvent that we put a standard. If something is soluble in water, we say it is soluble. And so now the question is, why water? Is it water can dissolve everything? No. It's not only the solvent, and it cannot dissolve everything either, right? So what is specific you have in the water that is dissolving everything, dissolving many compounds? So if you have a water molecule, it's written, it's a band, it looks like the band shape. 2 hydrogen, 1 oxygen is a band molecule. That's how it looks like. So it has some special property that make it unique, universal solvent. It can dissolve many compounds. First of all, what it has in what water has? The thing water has is called polar. Have you heard the word polar? What is it? Let's go like worldly term. You don't have to talk about chemistry. Second? Same magnetic field has a positive negative. In the world is divided, right? World is some countries very poor, some countries like very rich. Some people are very rich, some people are poor. Even in this country, in states, some people are very rich. Some people, there is not very poor people. Everybody is surviving, but compared to those rich people, the people surviving, they are very poor, right? So that means society is polarized. That means if you go that definition, then the world, the country have a lot of money, right? That money is divided to rich and the non-rich people. That means society, the money is polarized. A compound water has a O and 2H. This molecule has a lot of electron shared, and this sharing electron pulled by one then other. That's called polar. This compound is polar because oxygen pulling electrons from the bond of H and O. So electron cloud is more towards oxygen than hydrogen. That makes water polar. side. Get a quiz from there. Okay. And give me that.
Oh.
Okay. So, if any compound is polar as well, like water, so any compound is polar. It could be ionic compound, it could be covalent compound. If it is polar, that will be dissolved in this water molecule, being polar. That's called polar, like polar. Any polar compound can be dissolved into the another polar compound, like water. So what are they? First of all, the most important is ionic compound. Ionic compound is the number one types of compounds that dissolve in the water. So these are the polar compounds. Any example you can give me ionic compound, guys? What types of salt are you talking about?
Sodium chloride.
Sodium chloride is ionic compound. How do you know from the periodic table? If you have a periodic table, can you distinguish which atoms making ionic compound, which making covalent compound? All
Non-metal and metal.
all non-metal and metal forming ionic compounds, right? So, can someone please hand out this one? So in periodic table, as you see, all the metals. Anybody can tell you that what the metals, guys, from here?
On the right.
Right side are the non-metals, and all left, except few of them, all of them are metals. Some are main group, 1, 2, 3. They're called main group metals, and in the middle are called transition element, and they are also metals. So, metal and non-metal form ionic compounds. But all ionic compound is not, even though they are polar, it's not going to be dissolved in water. But most of the ionic compounds are dissolved into the water. So example, you said sodium chloride. If one metal and one non-metal, making it polar. So polar, look at that, sodium plus chlorine minus. That makes two different poles. It's completely electropositive, it's completely electronegative. That makes this compound polar, that will be dissolved in the water. What are the ionic compounds? What are the other ionic compounds is not dissolved in the water? We'll save that in the next section. Right now, ionic compound and what other molecule? Strong acid. Strong acid is the one also dissolved into the water, because strong acid can, yes.
Do the positive and negatives have to be balanced, or does it matter as long as you have one positive? Or
Very good point, guys. We'll talk about that in a minute. Let me save it for a few minutes later. Okay, we'll talk about that. How a compound needs to be balanced to be ionic compound. But at this moment, we are just talking about that any compound has ionic structure, which is metal and non-metal, that will be dissolved in water. And if that happens, that will be strong, that will be called strong electrolyte. What is electrolyte means?
It makes electricity.
Conduct electricity. Any compound can conduct electricity, that's called electrolyte. What do you understand when you hear the word electrolyte? Gatorade have electrolyte, right? So they made from electrolyte? They have some electrolyte, right? They have something dissolved in there, some electrolyte. Is it good, very good for health? No? What are you drinking? Is it good for health? Look at this, someone saying that this is good for health. I consider, based on my long years of drug research experience, this is the worst water you can ever imagine. No surprise, guys. No surprising.
That brand
not the brand. As long as it's in container, plastic container, that's the carcinogenic. You gotta be careful. You're paying your own dollar and getting the disease. You don't want that.
What about the metal ones?
What about Fiji, man? Fiji comes from waterfalls.
You said it doesn't matter as
So,
long as it's in plastic.
The time that stored in the bottle, right? They supplies through in many media, right? Via, and through the time it become different environment, and plastic can melt, react easily, dissolve easily, which makes water unhealthy. The best water, I would say, just filter it out, because you cannot get 100% clean water. Our body has a lot of ability to clean out the metals and poisons, but not at that level. You don't want to drink which is stored in the plastic for years or months. It's become hot, cold, different environment, and you're drinking that with a poison. How about the Gatorade? You like it, right?
It's good, that's why. Because then it's
Bad for your
refreshing.
teeth.
So, in Gatorade they have a lot of electrolyte, I agree with it. What if you drink like some, like an apple? Eat an apple. One apple have a lot of ions, a lot of vitamins, a lot of minerals, right? So, they're just saying, they're just saying, eat a one apple, never go to the doctor. You know that, right? It is true. A lot of people, complain that, oh, I'm in diet, but I'm still in fat. Right? I'm not in diet, so I'm fat. So I'm not complaining that I'm diet, But a lot of people does, right? So, because the processed food, right? I never saw my grandma was dieting. She lived 110 years. I never saw she had any disease. What's your comment?
How?
My dad is sick, I'm more sick. I'm not sick, I'm just giving example, Generation to generation, we are getting more weaker, more sick, right? Why? We are developing processed food, we are developing technology, right? Food claim we are the best generation, right? But what we are doing? We're eating poisons. We have to go back to our nature, right? We have to go back to eat, fresh food, freshly grown, freshly cooked, right? No bottle, no freezed, no preserved, no processed. We have to go back, we have to work hard to be healthy, right? I can't believe my kids get sick every month. It's been, but now I'm, after my research and I'm changing, Now they are not getting sick that much, So, need to be careful, right? Health is very important. And nowadays, enemy around. Everything is like poisonous, which is claimed based, right? We are not actually. So technology should be accepted in a certain way that doesn't harm us, right? We have a fridge, that's good. Fridge is good technology. You are refrigerating our food. I'm eating later. But what if deep, frozen? And my dad always think, hey, it's in the deep. It's good. Even deep fridge, food getting bad slowly, but it is getting bad. Deep fridge doesn't mean that okay, fridge is totally good. I can keep, I can eating after 1 month. Anyway, stay healthy. Stay with the nature. Okay. Strong electrolyte and weak electrolyte. So strong is the one which is ionic compound, and who else? Strong acid. What is strong acid? Only these 6. What the weak acid? Except these 6. These are the strong acid. So other than that, all acid are going to be weak. Same. This is the strong base. Except these 6, all acid going to be weak base. So strong acid, strong base, strong base, So these three are the soluble in the water. One more thing, any covalent compound has polarity. The reason water is strong solvent, it can standard solvent, because it is strongly highly polar. So any compound would have polarity. Any compound is a polar any compound we have a strong polar compound that will be also soluble in the water. So what does solubility means? What happens in the molecular level? Think about it. So I am dissolving this sodium chloride. This is stay as sodium chloride as salt, you know that. When in the water, it doesn't hang out together. Sodium chloride, they split it, so they split it up, chloride and sodium like that. So they in a water solution, they mixed up. So the salt dissolving means they split it, they hang out separately. They split it as their own ions. We're coming up here to your point. How they become balanced out. Okay? So now we need to learn their solubility. There's which compounds are soluble, which are not. As I said that all ionic compounds are not soluble. Yes, they are, but not all of them. Look at that. I have a big list of ionic compounds are not soluble. So we need to learn which are soluble, which are not. By this time, I handed out a page, right? You have that. So try to read out. First one. Group 1A ammonium and ammonium compound are soluble. So what is the group 1A? In the table. 1A, right? Lithium, sodium, potassium, rubidium, right? They are the group 1A. Any group 1A compound will be soluble. So how about if I write potassium sulfate? Is it soluble? It is, because potassium is group A. Group A metal coming with any non-metal, any anion. Remember that. One is called cation, anion. Positive charge, the metals is called cation. This is called anions, right? So how about ammonia? Like ammonium chloride. Is it soluble? Yes, it is, because it says ammonium compounds are soluble. Okay, one thing I was just trying to remind you that you guys, polyatomic ions, ammonium sulfate. Did you memorize the table? You have to. If you do not memorize, you cannot continue this chapter. You cannot look at the 6, 7 table at a time to solve a problem. Can you know? Polyatomic ion, valency, cation anion, and the solubility, and top of the you have periodic table. How many papers you guys would look at solving a problem? Not 10 of them, right? So you have to memorize the table. Make sure you know that. Okay. Couple of things. When you memorize polyatomic ions, sulfate, they are ions. They are coefficient, right? They are number of atoms, and sulfate is not always so SO4, which is called sulfate. SO3, right? Sulfite. So you have to know there very clearly so that you can read out. Look at that. When you read the salt, when you're splitting up, when you're dissolving calcium sulfate, you need to know that where it's going to be splitting. If we dissolve potassium sulfate in the water, so it's going to be coming potassium and sulfate. Right? We need to know that very clearly which one is the metal, which one is the atom, which one is the polyatomic ions. Because polyatomic ions have a single charge. Like sulfate is a 2-. Single charges. 2, 3 or 1 sometimes. Ammonium is a 1. NH4 is only 1 charge, single charge. Any questions so far? Let me go more practice about the solubility rules. Like group 2A, acetate and nitrate are soluble. Acetate, nitrate always soluble with any metals. Chloride, bromides, iodide are soluble except this. So let me ask you then, zinc chloride, is it soluble or not? Is it soluble? All chloride are soluble except silver, mercury and lead. You see? All iodide are soluble except silver, mercury and lead. How about AgI? Silver iodide, is it soluble? No, because it's in the list that are not soluble. Most sulfate are soluble except calcium, strontium, barium, silver, mercury and lead. How about magnesium sulfate? Let me ask you another question first. Did I write properly? Did I write proper magnesium sulfate here? Yes, magnesium is 2 plus, right? Because in group 2, sulfate is 2 minus, right? Yeah, your question was, how do we balance out when you write a molecule, right? It balanced out, for instance, magnesium was 2 plus. Sulfate was, so 2 minus. So 2 plus, 2 minus, they correspond, they are valency. Let me give another example in here, which is like potassium sulfate. Potassium sulfate, KSO4. Did you write properly? No? What's wrong with it? Why K2? I'll follow you, you're my teacher, but why?
Because its charge is +1 and so A is 2.
Because potassium came from potassium plus, right? Potassium 1 plus. But sulfate is 2 minus. To balance out, we need 2 potassium with 1 sulfate. 2 here. The way it works, they correspond their ions as a subscript. Ion was +1, sulfate would take 1. But we don't need to put 1 in the parentheses because they already have a 4 subscript. We don't need to add 1. But potassium will get 2 from there, the corresponding their charges as a subscript as a 2 in here. Right? One more example is like magnesium nitrate. Did I write properly? Magnesium nitrate? How that should be written?
Magnesium 2 nitrate.
Nitrate will be 2 because magnesium was 2 plus and nitrate was 1 minus. So magnesium will get 1, nitrate will get 2 from here. That's how it balanced out. That's how you have to know when we have a molecule, you need to know how to write it out. Any questions so far? So let's go one more example in here. Let's go to the last one, very last one. Or number 7. Most sulfide are insoluble except group 1A and ammonium. How about magnesium sulfide? Or zinc sulfide? Or sodium sulfide? Is it soluble? Yes. Because sodium is in group 1A, exactly. But this is not group 1A, so this is not soluble. Right? So read through this and you need to be able to distinguish soluble or not soluble. How about phosphate? Phosphate are insoluble except 1A and ammonium phosphate. So let me write out 2. So did I write properly here? Anybody can read this? Aluminium phosphate. Is it right?
Yeah.
Why it is right?
It's three.
They both are 3,
Yeah.
they balanced out, right? How about this one? Sodium?
That's
That was,
Wrong?
yeah.
Why wrong?
Is it NaOH?
Exactly. So phosphate is a 3, it will come 3 as a 3 sodium and 3 comes as a substrate. And phosphate doesn't need any parentheses, no more, because sodium only 1. I think that should be enough for you to start working. So then let's go to the chemical reaction, right? Let's do some reaction in here in the. Am I drinking water, guys? No, nothing. Don't be scared. No bubble. Be seated. So I'm doing chemical reaction. So suppose any reaction I'm doing, right? Let's see what happened. There you go. Something formed, right? So what I did, I put it. Let me write out in a chemical form. So somebody can give me what does chemical reaction mean? Definition, please. Just as a review. Any example of chemical reaction in a molecular form, please. So let's AB, right, plus CD. They're reacting together, forming AD, not AC. AD and no CD. If you're kidding, that's okay. Otherwise, not. What happened in here? Look at that. They're dancing, for instance, in a class, they're dancing, right? These two. This is a partner, this is another partner. After some time, they swap their partner. They switch partner. You see, that's happened. Only that's happened. D come to the B place, B come to the D place. You see? That's called double displacement. There's many types of chemical reactions, but at this moment I'll be talking about only 2, other I will be saving for later. So these 2 are, first one is double displacement. What do you mean double displacement? Look at that. 1 displacement, 2 displacement, right? 2 forming. That's called double displacement. If they displace each other and form a precipitate, S doesn't mean that's soluble. S means solid. Someone making a solid, that's I did, you see. I started with a 2 and after that they made a solid, you see. Solid here, right? That's called precipitation reaction. If two things reacting each other forming a precipitate, that's called precipitation. And other one is acid and base. Acid base reaction is if acid and base react with each other. This is also kind of double displacement. So react with each other forming salt and water. We'll go example. First of all, let's go over precipitation reaction. So if I write silver nitrate plus sodium chloride, it forming. Can somebody help me with how they displace each other? If chlorine comes here, what will be formed? HgCl. 2 or 3 or no? And the nitrate coming here, right? Remember? What is forming then? Sodium nitrate. Right? So now figure out from the table, is there all of them soluble or none of them soluble or any one solid? Quickly. AgCl is a solid, so that will be putting as a solid, right? So if not solid, that means they are soluble. Soluble, we can put a sign AQ, aqueous. Please do that. Aqueous. You see? And we have two more signs. So first sign is aqueous if any compound is soluble. Again, soluble means that is split in a water solution, right? We'll talk about that in a moment. So aqueous means water, and S means solid, which is precipitate, not dissolved anymore. And liquid is, something is liquid, only water. Liquid is only water. You might argue, why aqueous is not water? Why liquid means not aqueous, right? That's how they used it. They use the same symbol. And solid, you can argue that solid means soluble. Why solid means precipitate? It could be P, right? That's how they used it. Let's follow it. And then gas means something is gas, like carbon dioxide gas, sulfur dioxide gas. If it's product from, so based on the reactant and product from the table, we'll be signing them with this sign. So again, what AQ stands for? Aqueous, which is dissolved in water. How do you know dissolved or not? Soluble or not? From the table, right? Wonderful. And then solid. So this called molecular equation. We are writing complete form. And then we can, as I said, if it is soluble, how they stay in a splitting form? How they look like? Let's see. Silver will be coming as a silver plus. And both ion are aqueous. So silver is aqueous and nitrate also aqueous, right? Plus sodium chloride also aqueous. So sodium will come as a, please write with me, sodium plus aqueous plus chlorine also in a aqueous form. Then, how about silver chloride? I have silver chloride, right? How it is staying in here? You see that? Can you guys see? Is it split two part? No. The solid one. Solid is solid, right? Sitting there, not being split. But all of them being split except the one solid, right? It doesn't ionize. So solid silver chloride will be keeping as it is if it is solid, which is not soluble. Plus, how about the sodium nitrate? Then splitting. Ion means splitting. Ion means dissolve. Dissolve means ion separately. Again, I'm just repeating same word so that it will be clear. This is called complete ionic equation. Complete ionic equation. Okay, let's go step by step. Do this one. I want to see everybody do that.